Okay, so to perhaps answer some, or to complete some unanswered questions, that is, we never finished the rest of our note guide. When I printed them off, I just would glance at them and say, oh, it's already filled out for you. I mean, yes, that's fine and dandy, but really doesn't help us out here right now. Okay, so okay. But it seems to, I don't even have it turned on yet. That's why you can't see it. Well, tomorrow. So does this look somewhat accurate on where we are at? Does that sound right? We're down more, okay? Okay, so it's okay. So I don't think I have anything left on this slide, but I can certainly put the Word document up and then follow along in that manner. Okay. So the big point here, okay? Movements and maintenance of equilibrium. We did an exercise like that. How does your cerebellum play an important role in what we call equilibrium, allowing you to walk like this, whether typically it's in a straight line, but what allows you to do that? Well, it's this structure here, or the cerebellum. But that doesn't explain why it does that, okay? So what type of reflex or sensory information is that cerebellum receiving? It's one of your cranial nerves. What's it getting information from when you're doing this? Say that again? That's where it's at, but where does the information come from? Say that again. You're right. Oh, okay. The optic nerve. So that means that this is a reflex center, okay, to where, who can we pick on in here? Okay? See, with friends like that, who needs enemies, right? Means sometimes they're one and the same. You did? Oh. See, maybe my short-term memory's lacking. What did we do yesterday that we picked on you? Oh, but that wasn't me. That's why I don't remember. Okay, I agreed with you. So, yeah. So, see, why did you flinch? She thought you were going to get hit in the head. So, typically, how did you know to blink your eyes and move? Where did that information come from? Say it again. Your optic nerve. So a reflex center, okay, could be, I asked this simple question because I didn't know the answer. To me, it makes sense, but some of you have to make a split-second decision just like that, and that is, if you are playing the back row in volleyball, how do you know whether to hit? Because I'm going by an answer that so I'm going to ask this question and let me answer it and see if it reflects what you were told. You're playing in the back row. How do you know whether to hit past the, well, Is this still a pass when you do this? Okay, and this isn't always just a pass. Okay, so how do you know whether to do this pass, or whatever? My answer that was given, because I didn't know, is it if it's coming at the same height as your head, your shoulders, or what? If it's over your head, do you let it go? Or that split-second decision, I'm sure sometimes when I'm watching, okay, said a lot of times reading a lot of your papers at night, okay, maybe not just this class, but all classes, I'm watching that. So all players, who can we pick on? Okay, so I might be thinking in the back of my, you should have let that go because it's probably going to be out. But how do you make that decision right now? It is a guess, but what gives you the best information to make that best guess? Okay, but what height to your body do you make that split-second decision? Say, I'm going to hit it. If it's above your head, okay, and that's the way it was explained to me too. That works for you. So, do you ever think, dang it, I should have let that go? Yeah. Does it happen more often than you would like? Probably not. Okay. So I think that's one half of that, but what about, can you see that sideline and you're going like this, and it's not that you can't go over, we all know that, but do you ever find yourself standing, your legs are on each side of the line, and then you decide to let it go, then it hits the line? I'm sure that's happened to everybody, right? So how do you make that quick second decision? Kick it. That makes no sense.
If it's about to go on the line, I would kick it.
Oh, okay. I'm sorry. I couldn't hear. You might have said something, I couldn't hear it though. Okay, but then you have to process that really quickly though. And your brains are able to do that.
A lot of the time it's like it's close to the line and you're still going for it and somebody calls it out, you'll still like.
So is that frustrating for your teammates? You find out that depends how far. Oh, okay, I would agree with that.
But if it's 5 feet out of bounds, then it's.
You're like, ah.
Sometimes they call it out unintentionally. I just don't trust them.
You know, okay, that brings up a good point. Not for volleyball, but I know some of you don't follow baseball. I do. Okay? You can't do it for football. You can do it for volleyball. You can't do it for basketball. I'm talking about officiating. In baseball, it's umpires. Of course, officiating in basketball, it's you have an umpire or you have a referee and two it doesn't make any difference. But with baseball, should computers judge the strike zone? See, because that goes back to your statement, you can't trust the line judges. So is it fair to say that there's a human component into officiating the volleyball? That's what that would mean, because you can't trust them. So does that answer the question that it should be computerized, line judging? And yeah, people don't understand that though. It's part of the game. Bad calls is just part of the game.
There's also a lot of look at, so I mean not really, kind of. It's not, yeah, you're not perfect. I mean, you make mistakes.
But I think people expect that to be done perfectly. See, a lot of people understand that I've line judged before, and I get it, because I think we all would agree that I need to hit pause here for just a moment and then get this up on a Word document. Okay, as you can see, I don't have this in PowerPoint, but I think It's hopefully big enough that you can read it. Would you like this enlarged? Okay, so let me give that a try, and hopefully it doesn't distort. How's that? Okay, so we've talked about these cranial nerves, which we know that there are 12 of them. So what is the division of these cranial nerves? What does it say? Some do this, some do this, but what's a third option? It's clear and concise that olfactory and optic are purely and solely what type of cranial nerve? Say that again. If you smell things or see them, that's purely what? That's sensory, okay? Then the third cranial nerve is called your oculomotor, so then that's purely just what then? When it moves the eyes, that's just purely a motor nerve. But, so some cranial nerves are just sensory only, some of them are just motor only, and then some of them are a third type, which means they can be what? Right here, mixed. So what does that mean to you if it's mixed? It's both sensory and motor nerves, okay? So, for instance, if this is referring to what part of your nervous system when you just see somatic, what does that mean to you? What is that controlling? You know the answer, you just need to think about it just a little bit. I'm doing it right now. Say that again. Okay, the somatic nervous system controls your somatic. No, I said that wrong. Your somatic division controls your skeletal muscles. That's why stand here and wave this pen. Okay? So what does this mean if it's autonomic? What are two divisions of your autonomic nervous system? Two divisions. Parasympathetic and sympathetic. But that doesn't explain the difference between the two, though. So what is the difference? There has to be a reason for that they're named differently, which there is. Okay? So why might it be called the sympathetic portion? This would be something that, say that again? It could be, but I think a better example would be, you're driving to someone else's house, okay? So we need two people. Okay, so, and that's a good example because what do you suppose the distance is between your two houses? 12 miles? No, you don't have to agree with me. So who's driving where?
I'll drive to
Okay, so your lab partner, and you know what I mean by lab partner. If you're sitting at a table, I always just refer to that as your lab partner. Okay, so you are driving to her house. Your lab partner tells you, what might be something that you would bring to your lab partner's house?
a bubbler.
You two don't count. What's a bubbler?
It's that thing that she
Oh,
Sparkling water.
oh. I thought it was something like a machine that spits out bubbles is what I thought it was. Okay. So don't forget the bubbler. Man, you just passed on Highway 34. You just passed the sign that says Del Rapids 10 miles this way. You forgot the bubbler. So when that thought enters your mind, what might happen?
Turn around, go get
Well, that's what you're going to do, but that's after the initial thought. Because this is life or death, the bubbler. And you forgot it. You might be mad. But what might be happening inside of you? You're really, really close. Are you scary? You are now. Okay. Okay.
You forgot the bubbling.
Because sometimes what happens if you forget something that's critical, why is your heart rate going up? Because you just said what? Fear can certainly cause that. Okay? But you don't have any conscious control over that fear, do you? You don't have conscious control over it, but you can deal with it. Because that's what might be your response is, sorry, I forgot the bubbler. You're just going to have to deal with it. Okay? So that's an example of what happens inside of your autonomic nervous system. Okay? The sympathetic portion. So then what is the other half of that then? The what? The parasympathetic division. And that's what happens at night. You could say that is your rest and repair division, because one of the things that happens when we say, if it's substances like caffeine and sugar, okay, this is not part of your parasympathetic division. What happens, that gives you energy, right? So when you get energy that's going up and up and up, eventually that's going to come back down, right? And it happens with kids if they eat a lot of sugar. All of a sudden they have all of this energy. Then we could say, what, 2 hours later, what do they call that? A crash, okay? Do you experience that at home with a daycare? You can probably tell some pretty good stories, right? And not that we're going to spend time on that, but what happens in your autonomic nervous system, just like that sugar or that caffeine, you have hormones that are rising and causing a response. It's going up and up and up in your sympathetic nervous system. Eventually, your parasympathetic division is going to have to bring that back down, okay? Because if it doesn't, you don't want your heart beating at 120 beats per minute for an extended amount of time. It's just not healthy for you, and I think you would agree with that. Okay. So then, do we know how many vertebrae you have? There's 3 different types, but that doesn't explain how many you actually have. Okay? But you don't have 31 vertebrae. Okay? You have 7 cervical, 12 thoracic, that's 19. 5 lumbar gives you 30, or 7, 19, 24. So what is it that's causing this to go from 31 if we only have 24 vertebrae? Well, there's also 2 lower bones in your vertebral column. And from biology, when you were told to know these, what are those 2 lower bones called? One starts with an S, sacrum. The other one's what? Coccyx. But the coccyx does not have any holes in them or foramen, but your sacrum does, okay? So those other 7 pairs go through your sacrum, okay? Yes, please go do that. Okay? Yes, ma'am. So here's what we're talking about, sympathetic division. deals with that stressful and emergency conditions. Because what did you do? So that might put you in a stressful situation because we're scared. So that's just laughable to say that you're scary. Right? That'd be the same as saying you're scary, or you're scary, or you're scary, or anyone in here is scary. That's just laughable. Are you scary? You? Don't know? So, oh, okay. Well, maybe you are scared. I don't know. That's not for me to answer. Okay. So when we look at this, the sympathetic division, you are responding to stressful situations. Your heart rate is going up and up, but it has to come back down again. That is controlled by your parasympathetic division. That's why we call it the rest and repair portion. Okay. Do we possibly remember from prior knowledge, what is acetylcholine? No. Yes, it's also in the PNS as well. Okay, so to make sense of that, we've seen it in these regards. This isn't on a slide, is it? So I need to do this. Okay. All right, and that is as follows. Okay, you've seen it in this manner. Okay, we'll try to make this somewhat accurate because I need a red color. Okay. That's not a blood vessel. We'll just what type of muscle do you have in your small intestine? Smooth muscle. What type of muscle do you have in your, I almost said fingers. Do you have any muscles in your fingers? Why are you right? Because you're right. Where are the muscles that move your fingers? Yeah, they're actually in your wrist, okay? So whether it's your flexor or extensor digitorum, because that's something that you're going to have to know next semester, or of course your biceps, okay? You're doing this, or we're scratching our heads or something like that. You're moving some of these muscles, but what happens is, I think we had talked about this. Maybe we didn't draw it, but I do remember this. What does this resemble possibly on a door? A doorknob, okay? It's better to draw a doorknob than be one, right? Right? You know, maybe, yeah. Okay, so with this, notice, does a synaptic knob come in contact with a skeletal muscle or striated muscle? No, it doesn't. So how does a synapse that's moving in this direction from an axon, how does this information get from here? These little triangles are called neurotransmitters. That's what they are. You're not wrong, but they have a specific name. Because there's more than one neurotransmitter. Okay? But what's the specific name of that neurotransmitter? You're going to say, it starts with an A. Acetylcholine. So this acetylcholine comes off of this synaptic knob and stimulates this striated and or skeletal muscle. But you don't have them only in your somatic nervous system. You have them in your autonomic then as well. Okay? This is the price I pay for not having this on the overhead. Okay. Okay. So then when you look at this, okay, both the sympathetic nervous system and parasympathetic nervous system, how would we know that this is not peripheral nervous system? That's a tough question. How do we know that that's not the peripheral nervous system? Because you're talking about what? I could only hear half of it. Okay? Well, if this is sympathetic and this is parasympathetic, look at what it's under. The autonomic side. That's how you know that it's not the peripheral nervous system. It has to be the parasympathetic. What do you suppose we mean? That's where the similarities end, that they both secrete acetylcholine. Why would we say that? They both secrete it, but why is that where the similarities end? What's this? It is, you could say. But what do we say? Caffeine, sugar, these hormones, this adrenaline causes what to go up? Your heart rate, okay? Well, if that's going up because of hormonal action, we also have to have a way to bring that back down, and that's why these have opposite actions, okay? You're still secreting acetylcholine, but that's the only similarity that they would have in common. Okay, where does that? So then I think from here on out you have, it talks about the general senses, the special senses, and then the functions of your cortex. Is that what's left? Okay, so then you just have examples of, well, what is consciousness? That means you are awake and aware of your surroundings. I think is possibly what it might not be the first one that you see, but the four functions then, of course, are, again, coordination, speech, emotions, and memory. Okay? So what might be a general sense? Okay? Okay? Yes, feelings like touching things with your fingers and temperature. But then how is that different from a special sense? What is more complex though? What are you hearing? You're processing that sound. That is a special sense. And where's that special sense located? In your ears. So you can hear it, but you can also see it. Okay? I could change the beat maybe, or go slower, or go faster. Okay, so we're running short on time, so I believe you have everything that you need. I'm just going to ask, just answer the question the best you can. How many of you have a lot left on these papers? I said a due date of tomorrow, so asked and answered, okay? Why don't we say, if we had this out here, okay? I don't know when we assign them. I'll just say I assigned them here. Assign worksheet 11. Let's go for 11/1. When's that? Wednesday, because this is the 31st and this is the 1st. Okay, so Wednesday, November 1st. All right, so that's all I have. We'll catch up to you next time.